Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss integrals. Today we are going to discuss integrals. In this chapter, we are going to discuss the problems in the exercise 7.1. The problems in the exercise 7.1. Page number 299 in the textbook. Page number 299 in the textbook. In the previous class, we have completed 11 questions in this exercise. We have discussed 11 questions in this exercise. Now let us start with question number 12 today. Okay, my dear children, are you ready to listen the class? Right. See the 12th question. Find integral x cube plus 3x plus 4 whole divided by root x dx. Okay, my children, understood? We have to find integral of this function. Now, come to the solution part. You know that the first step is we have to assume. We have to consider the given integral is capital letter I. So, let I is equal to integral x cube plus 3x plus 4 whole divided by root x dx. Understood this first step, my children? Right. Now, if you observe this integrand, here numerator is an algebraic expression divided by a monomial. Root x is a monomial. As if we followed for the previous questions, here also we follow the same procedure. Okay, my children. So we divide each and every term by this monomial. Okay, my children. So integral x cube by root x, I wrote the first term integral x cube by root x dx plus, understood this first term, my children? Right. Plus integral 3x by root x. Integral this is the second term. Understood the second term, my children? Right. Plus for third term integral 4 by root x dx. Integral, understood this last term, my children? Just we have splitted the given integrand into three integrals. Okay, my children, understood this step? Right. Now come to the first term. Integral x cube by root x dx. Okay, my children, in the denominator, if you observe it is root x, it is called radical form. Let us convert this radical form into exponential form. That is equal to integral. How do you write this radical form in the exponential form? Yes, x power 1 by 2. Root x can be written as x power 1 by 2. Do you remember this point, my children? Right. Plus, here 3 is the numerical coefficient. So, we wrote 3 before the integral sign. 3 integral x by. Here also we are using the same property. X to the power of 1 by 2. Root x is written as x to the power of 1 by 2 dx. Understood the second term, my children? Right. Come to the third term. Plus 4 is a numerical coefficient. So 4 into integral 1 by x to the power of 1 by 2 dx. Understood this last term, my children? Understood this step? Because root x can be written as x to the power of 1 by 2. So, by using this result, we wrote this step. Understood this step, my children? Right. This is equal to, now come to the first term, integral x cube by x to the power of 1 by 2. If you observe this function carefully, it is in the form of a power m by a power n. isn't it or not, my children? So we use that loss of exponent. So where a is equal to x, m is equal to 3 and n is equal to 1 by 2. So x power a power m minus n dx. Understood this first term, my children? Right. Plus come to the second term. 3 into, we use the same loss of exponent here. 3 integral x to the power of here, we assume that there is 1 as exponent. So x power 1 minus 1 by 2 dx. Understood the second term, my children? Right. Plus 4 integral, this can be written as x power minus 1 by 2. This is also one of the laws of exponents. Okay, my children, understood this last term? I will write here which laws of exponents are used to write this step. A power m by a power n is equal to a power m minus n. We used this laws of exponents for the first two terms, and 1 by a power n. This is also one of the laws of exponents. We used this laws of exponents for the last term. Understood the step, my dear children? Right. That is equal to, let us come to the first term. X power 3 minus 1 by 2. Let us simplify the exponent. What will you get exponent? 2 3 is 6 minus 1, 5 by 2. X power 5 by 2 dx. Understood this first term, my children? Right. Plus 3 integral, come to the second term. Here also we simplify the exponent of x. What will you get? X power 2 ones 2 minus 1, 1 by 2. Understood this is the second term, my children? Right. Plus 4 into, we write the third term as it is. X integral x power minus 1 by 2 dx. I wrote this last term as it is because the first two terms are also in the form of x to the power of n. So I use the integral formula, integral x to the power of n dx in the next step. That is why I wrote the last term as it is. Understood this step, my dear children? Right. This is equal to, if you observe the first term, come to the first term, it is in the form of integral x power n dx. Do you remember the formula, my dear children? Yes. X power 5 by 2 plus 1 by 5 by 2 plus 1. We found the integral of the first term. Understood this first term, my dear children? Right. 3 into, here also we use the same integral formula, integral x to the power of n dx. So x power 1 by 2 plus 1 by 2 plus 1. Understood the second term, my dear children? Right. Plus 4 into, for the last term also we use the same integral formula. So x power minus 1 by 2 plus 1 by minus 1 by 2 plus 1. X to the power of minus 1 by 2 plus 1 by minus 1 by 2 plus 1. Understood this last term, my dear children? Understood this step? Right. Now what is the formula we usually hear? Integral x to the power of n dx. We use this formula, that is equal to x to the power of n plus 1 by n plus 1 plus c. We used this formula for this step. Okay, my children, that is why I wrote the formula. This is equal to integration formula, integration part is over. Now we have to simplify each and every term. Well, come to the first term, x to the power of, what will get 5 by 2 plus 1. 2 ones 2, 2 plus 5, 7, 7 by 2 by denominator also we get the 7 by 2. Okay, my children, understood this first term? Right. Plus 3 into, come to the second term, 3 into, what will you get x power? 1 by 2 plus 1, 2 ones 2, 2 plus 1, 3, 3 by 2, x power 3 by 2 by denominator also we get the same 3 by 2. Understood the second term, my children? Right. Come to the third term, plus 4 into x power 2 ones 2 minus 1. What will you get? 1. X power 1 by 2 by 1 by 2. Understood this last term, my children? We have simplified the each and every term. Again, let us write that terms in the particular order. That is equal to, this can be written as 2 by 7. 2 by 7, because 7 by 2 is there, it's reciprocal. We write it's reciprocal. Into x power 7 by 2. Come to the second term. 3 into here also we write the reciprocal. In 2 by 3. 3 into, we write it's a reciprocal. Okay, my children, understood? Right. 2 by 3 into x power 3 by 2. Come to the third term. 4 into, here also we write it's a reciprocal. 2 by 1 into x power 1 by 2. Understood this step, my children? Right. This is equal to 2 by 7 into x power 7 by 2. Let us simplify here. 3 gets cancelled. Plus 2 into x power 3 by 2 plus 4 2s are 8. 8 x power 1 by 2. We have simplified each and every term up to at the utmost level. This is the integral of the given function. This is the last step. So we finally, for the last step, please remember this point, my children. We have to add constant of integration plus c. Understood this step, my children? Right. If you want to check whether the given answer, this answer is right or wrong, find the derivative of this function. Then we get the given integrand. Okay, my children? That is why it is called antiderivative. Understood this point, my children? Right. Now come to the question number 13. Next question. Question number 13. Find integral x cube minus x square plus x minus 1 whole divided by x minus 1 dx. Understood this question, my children? We have to find integral of this function. Now come to the solution part. Let us assume that given integral is capital letter I. So capital letter I is equal to integral x cube minus x square plus x minus 1 whole divided by x minus 1 dx. Understood this first step, my children? Yes. That is equal to, if you observe this integrand, here in the numerator an algebraic expression, here in the denominator also an algebraic expression, binomial. In the previous questions, monomial is given, here binomial. Binomial means two terms are there. Okay, my children? So we have to divide this algebraic expression by this algebraic expression. If it is possible, we can write the factors of this numerator. Okay, my children? Let us write the factors of the numerator. If you observe for the first two terms, we can factor, common factor is x square. We can take it out. So x square into, from the first two terms, I have taken the common factor x square. I have taken out. Then what will you get? X minus 1. from the first two terms only. Understood this for first term, my children? Right. Plus x minus 1. I am writing the next term and the last term as it is, x minus 1. Understood the part, my children? Right. Whole divided by x minus 1 dx. Understood this step, my children? Right. Now we split into two integrals. We split this entire integral into two integrals. Okay, my children? That is equal to integral x square into x minus 1, x square into x minus 1 by x minus 1. Understood this first term, my children? Right. This is the first term. Now come to the next term, second term. Plus integral. This is the second term. Now consider this is entire part is the second term. So x minus 1 by x minus 1 dx. Understood this is second term, my children? Right. Understood this step? Right. So integral here x minus 1 gets cancelled. Then what will get here? X square dx. We simplified the function. Okay, my children? Understood? This first term. Right. Plus integral. Here also x minus 1 gets cancelled. 1 dx. Integral 1 dx. Understood the second term, my children? Right. This is equal to, if you observe this integral first term, it is in the form of x to the power of n dx. Integral x to the power of n dx. So we use that integral formula. So x to the power of 2 plus 1 by 2 plus 1. Understood this first term, my children? Right. Plus integral 1 dx. What is the formula? X only. Do you remember that formula, my children? I will write here. Because integral x to the power of n dx is equal to n x to the power of n plus 1 by n plus 1, and integral dx is equal to x. By using these two integral formula, we wrote this step. Understood this step, my children? Right. So integration part is over. Now let us simplify the terms. This is equal to, what we will get here? X to the power of 3. That is x cube by 3 plus x. We simplified the terms also. This is the last step. So you remember this point. At the last step, we have to add constant of integration. So plus c. Since this is the last step, we have to add constant of integration. So we added constant of integration plus c. Understood this step, my children? Right. Now come to the next question, that is question number 14. Question number 14. Find integral 1 minus x into root x dx. Understood this question, my children? Right. Now come to the solution part. Let us assume that capital letter I is equal to integral 1 minus x into root x dx. This is the first step. I previously told you, we have to assume that given integral is capital letter I. So this is the first step. Understood this first step, my children? Right. That is equal to, let us use here distributive property. Okay, my children? Right. That is equal to integral root x 1 into root x. What will you get? Root x minus x into root x. What will you get? X root x dx. Whole dx. Understood this first step, my children? By using the distributive property, we wrote this function. Okay, my children? Right. This is equal to, root x can be written as x power 1 by 2. So x power 1 by 2 minus x into x power 1 by 2. Understood this step, my children? Because By using this property, we wrote this step. Understood this step, my children? Right. This is equal to integral x to the power of 1 by 2 minus, here if you observe the second term, it is in the form of a power m into a power n. So we use that laws of exponents. Okay. X power 1 plus 1 by 2 dx. Because a power m into a power n is equal to a power m into a power n is equal to a power m plus n. By using these laws of exponents, we wrote the second term. Understood the second term, my children? Right. That is equal to integral, we write the first term as it is, minus x power, what will you get here? Exponent of x, 2 ones 2 plus 1, 3 by 2 whole dx. Understood this step, my children? Right. Now we split into two integrals because the integrand is a combination of two terms. So we can find the integral of each and every term separately. So that is equal to integral x to the power of 1 by 2 dx minus integral x to the power of 3 by 2 dx. Because integral f of x plus or minus g of x dx is equal to integral f of x dx plus or minus so by using this property we wrote this step. If the integrand is the sum or difference of two functions, then we can find like this. Okay, my children, understood this step? Right. If you observe the first term, it is in the form of integral x power n dx. So we use that formula. So x power where n is equal to 1 by 2. So x power 1 by 2 plus 1 by 1 by 2 plus 1. Understood this first term, my children? Right. Now come to the second term, minus, it is also in the form of integral x to the power of n dx. So x to the power of 3 by 2 plus 1 by 3 by 2 plus 1, because integral x to the power of n dx is equal to x to the power of n plus 1 by n plus 1. By using this formula, we wrote these two terms. Understood this step, my children? Right. Integration part is over. Now let us simplify the terms. This is equal to, what will you get here? X to the power of 1 by 2 plus 1. We get 3 by 2 by 3 by 2. Understood this first term, my children? Right. Minus x to the power of 3 by 2 plus 1. What will you get? 5 by 2 by 5 by 2. Understood this second term, my children? Right. That is equal to, this is the final step. We write its reciprocal. So 2 by 3 into x to the power of 3 by 2. Understood this first term, my children? Right. Now come to the second term, minus 2 by 5 x to the power of 5 by 2. Understood this second term, my children? So this is the final step, last step. Do you remember that point, my children? We have to add constant of integration at the last step. So plus c. Understood this step, my children? Right. There are 6 more sums. 6 more sums are there in this exercise. Please try yourself the remaining sums in the exercise, my dear children. Will you try yourself the remaining sums in the exercise, my dear children? Right. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my dear children. I am not explaining the remaining sums in this exercise. Please try yourself the remaining sums in this exercise, my dear children. Okay, my dear children, because there is no time. time limit is there. We have to complete the syllabus also as well. That is why I am giving the questions to you. Okay, my children, please try them. Okay, right.